In this lesson, you're going to learn how to solve a quadratic equation using the grouping method. Let's take a look at the first example. In a previous lesson, you learned that if you have 4 terms in your polynomial, there's a possibility you can factor this using a method called the grouping method. So let's take a look and see if it works in this case. Now for this purpose, although we do have 2 like terms, 12x and negative x, because we're practicing the grouping method, we're not going to combine the like terms. So what you want to do first, as in any quadratic equation, is look and see if there are any common factors for the 4 terms. And if you look carefully, there are no common factors of the numbers or the variables. So because there are 4 terms, you can automatically try the grouping method. So let's group the first 2 and the last 2 terms together. From here, if you look at the first binomial, you're going to factor out the greatest common factor. For the coefficients 4 and 12, the greatest common factor is 4. For the variables, they both have an x in common. So the greatest common factor will come to the outside of the parentheses, and then we'll simplify the inside to see what remains. 4x squared divided by 4x, if we remove the 4's because when we divide those they equal 1, and we subtract the exponents of the x's, we simply have an x left. For our second term, 12x divided by 4x, the 12 and 4 divide to 3, and the x's cancel. And let's move this parenthesis over just slightly. When we move to the second set of parentheses, you'll notice, hopefully, that the signs of the 2 binomials are different. That signals you to factor out a negative number for at least one of them. Usually the second one is the one that most people factor the negative out of. So the greatest common factor, because there is no common factor of the x and the 3, but you can factor out a negative 1, which will change the signs to give you matching binomials to allow you to actually factor using the grouping method. So let's bring the negative 1 to the outside. And when we simplify the binomial, we'll end up with an x and a positive 3. So notice our binomials match. So from here, we can drop down our matching binomial, just one of them. And then if you recall, to get our second binomial, we take our greatest common factors, combine them together into one binomial, which would give us 4x minus 1. And then we have the equals 0 at the end. So in these we're actually solving, which means we're going to take the problem one step further because we want to find what x would equal in order to get our x-intercepts if we were to graph this equation. So we're going to get 2 answers when we solve this. Okay, and to do this, we want to set each binomial equal to 0. So we have 4x minus 1 equals 0, and x plus 3 equals 0. So if we solve these 2 equations, starting with the first, our first equation is going to give us an x-intercept of 1/4. Our second equation, when we solve it, will give us negative 3 as an x-intercept. So for most of these with the grouping there, you should end up with 2 different solutions, which are the x-intercepts of the graph if we were actually to graph the parabola for this equation. Let's look at an additional example. 2x squared plus 8x plus 5x plus 20. If we first look at the 4 terms in the polynomial on the left side of the equal sign, if you look at all 4 terms, there is no greatest common factor of the 4 terms. So we'll jump to grouping them together and then factoring out the greatest common factor. For the first 2 terms, you can factor out a 2 for the 2 and 8, since 2 goes into both 2 and 8. And for the x's, they both have one x in common. We will drop this down, and then we will see what remains. So 2x squared divided by 2x, when we subtract the exponents of the x's, leaves us with an x. 8 divided by 2 is 4, and then the x's cancel. For this, sorry, that's a fire drill, so hold on just a second. Sorry about the interruption. My school just had a fire drill, so let's continue. All right, we were working on factoring out the GCF, and we're starting on the second binomial. So the GCF would be 5. So we'll drop that down. Then we'll cross out the 5s and leaves us with an x. And then 20 divided by 5 is 4. And again, you can see that our binomials match. And then we're going to create a binomial out of our greatest common factors, and that'll be a positive 5. So we should have 2x plus 5 as one binomial, and x plus 4 as the other, and we'll set that equal to 0. Okay, and we're going to create two equations. So we'll have 2x plus 5 equals 0, and x plus 4 equals 0. Then we're going to solve these equations to find the x-intercepts of the graph of this equation. So 0 minus 5 is negative 5. When we divide by 2, our first x-intercept is negative 5 halves, or negative 2.5. In the second equation, our x-intercept is negative 4. So our two x-intercepts are negative 5 halves and negative 4. If you ever wanted to check those answers to make sure they're correct, you would plug both of them back into the original equation for all three x's, calculate everything on the left side of the equal sign, and it should come out to 0 if your answers are correct. Okay, let's take a look at another example. Now in this example, when you look to see first if there is any greatest common factor for all 4 terms, there is in fact a common factor. All 4 terms can be divided by 3, but they don't all have an x in common because the negative 24 has no x. So we're going to first factor out a 3. That would leave us with 3x squared plus 12x minus 2x minus 8. So now we're going to do the grouping method of factoring for the remaining polynomial in parentheses. So we're going to drop down the 3 and put brackets, and then we're going to start factoring out the GCF of each binomial. So for the first binomial, the GCF of the numbers is 3, and of the letters is x. So we'll drop down the 3x and then divide to get our remaining binomial. So the 3's will cancel, and we'll subtract the exponents, giving us an x. 12 divided by 3 is 4, and then the x's cancel. For our second binomial, the greatest common factor, we're going to factor out a negative 2 because notice the middle signs are different. And again, that's our clue that we need to factor out a negative factor. So we're going to factor out a negative 2, and this will give us negative 2. Then the negative 2's will cancel, so we have an x plus 4. This way, our binomials match. We'll create a binomial out of our greatest common factors. So we'll have 3x minus 2 as one binomial. Then our matching binomials will drop one down, so x plus 4, and set it equal to 0. Now we're going to go ahead and solve two equations. So we're going to set 3x minus 2 equal to 0 and x plus 4 equal to 0. And we can add the 2 to both sides. Divide 3. So one of our x-intercepts is 2/3. For the second equation, if we subtract 4, our second x-intercept is a negative 4. So our two x-intercepts are 2/3 and negative 4. The greatest common factor that you pulled out at the very beginning, the 3, does not have any impact when you're actually solving. So once you factor it out, it's not needed. If you are just factoring, you would need to make sure and leave that 3 in your answer. However, when you're solving, it's not relevant for this particular problem. Here the problem says find the x-intercepts, which just means to solve this like we did in the previous problems. So it says find the x-intercepts by solving the quadratic equation using grouping. Then use the given vertex and the x-intercepts that you find to sketch the graph of the quadratic equation. Now, the reason why it says y equals is just simply because we're graphing. When we actually are going through the process of solving, we're going to go ahead and set it equal to 0. Okay, so for graphing we use a y, but for solving we set it equal to 0. So if you look at all four terms, there's no greatest common factor of all four terms. So we'll move to grouping, and we'll factor out an x in the first set of terms, and we'll factor out a -2 in the second set of terms. So for the first set of terms, when we factor out the x, we'll be left with x minus 2. And for the second set, we'll have a -2 that we drop down for the greatest common factor. And then we'll be left with x minus 2. So we have matching binomials. Then we'll create a binomial from our greatest common factors. Now notice the greatest common factor makes x minus 2. Then our matching binomial is also x minus 2. So here's an example where, because our binomials are the same, when you solve these two equations, you're just going to get the same answer, which means there's only one x-intercept. So x equals 2 is what you would get obviously for both, but you only have to identify one of them because it's really one and the same. So what does it look like when you only have one x-intercept of 2? Well, notice the vertex is the same, and that there's a reason for this. So if the x-intercept is 2, 0, here we can locate it on the graph. What that means is that it is also the vertex. So if there's only one x-intercept, then it should always match the vertex. Now, in case you're not aware, the way that you know whether to draw your parabola going up or going down is based on, if you go back to the original polynomial, I'm going to circle it right now. If this is positive, if the x is positive, then you know that the parabola goes up. If that would have said -x², we would have drawn the parabola down. So we're going to draw a parabola up, and we're just sketching it, making sure our vertex or minimum value of the parabola is at 2, 0. And that completes the lesson on solving a quadratic equation using the grouping method.